Your AC unit is lying to you about what's actually making your house hot. It isn't the outside air that's cooking you alive every summer. It's your roof converting sunlight into radiant heat and pumping it straight through your ceiling. And there's a $2 powder sitting on every hardware store shelf right now that stops that process completely. Not partially, completely. The ancient Greeks figured this out 3,500 years ago, and they never needed a single machine to stay cool all summer. A Purdue University professor proved in 2021 that this exact powder generates more cooling power than the central AC system running in your home right now. And a $300 billion industry spent the last 70 years making absolutely sure you never connected those two facts. Today, we're pulling the physics apart layer by layer and showing you exactly why a $2 powder beats a $3,000 machine, and why the answer has nothing to do with luck and everything to do with thermodynamics. What your AC unit actually does is why it's already losing before it even turns on. Here's what most people believe. Your AC cools your house by pumping in cold air. That's not what it does at all. Your AC unit removes heat that's already inside your home and dumps it outside. It's a heat mover, not a heat stopper. And here's the physics problem your AC company never wants you thinking about. While your AC is moving heat out one end, your roof is pouring it straight back in the other. A standard asphalt shingle roof absorbs between 85% and 95% of all incoming solar radiation. That absorbed energy converts directly to heat and conducts right through your roof deck into the attic below. Attic temperatures during summer regularly hit 140 degrees or higher in most American climates. That heat then radiates downward through your ceiling into every room in your home, 24 hours a day, all season long. Your AC isn't fighting the outside air temperature, it's fighting your own roof. Call this the solar loading trap. The moment sunlight hits your dark roof, your AC is already behind, spending the majority of its energy just counteracting the heat source sitting directly above your head. That's why your AC runs constantly on hot days, even in a sealed, fully insulated house. It's not losing to the outside air. It's losing to the roof you're living under. And the powder fixes the solar loading trap at the source before that energy ever becomes heat inside your home. But to understand why it works, you need to understand what the Greeks actually discovered. The physics behind it is wilder than anything the cooling industry will ever tell you. Now here's a question worth locking in before we go further. What percentage of sunlight does a standard white commercial paint actually reflect? Is it A, 50%, B, 65%, C, 80%, or D, 98%? Drop your answer in the quiz below, and we'll come back to this. The solar bounce effect is why color is the most powerful cooling technology ever invented. Every surface on Earth has something called a solar reflectance index, which measures what percentage of incoming solar radiation a surface bounces back instead of absorbing. A dark asphalt roof has a solar reflectance index of around 5 to 10%, meaning it absorbs 90 to 95% of every photon that hits it. Standard commercial white paint, the stuff coating most white rooftops across America, reflects around 80%, which sounds good until you run the actual thermal numbers. Even at 80% reflectance, that remaining 20% absorption still generates enormous heat loads across a large roof surface. A 1,000-square-foot roof receiving full summer sun still absorbs the thermal equivalent of 2 to 3 kilo of continuous heat, even with commercial white paint doing its job. But the powder, hydrated lime, calcium hydroxide, the exact same material the Minoans were using on Crete in 1500 BC, reflects 95 to 98% of all incoming solar radiation. That's the solar bounce effect, and it doesn't just reduce heat absorption, it nearly eliminates it entirely. A 1973 study at Lawrence Berkeley National Laboratory proved the mechanism directly. Researchers painted a flat rooftop with simple powdered limestone mixed with water. The same recipe Greek grandmothers had been using for 3,000 years across the Mediterranean. That roof surface temperature dropped 40 degrees Celsius compared to an identical dark roof sitting right beside it. Interior building temperatures fell 8 full degrees, and the building needed zero air conditioning that entire summer. Now, you're probably thinking, if this is actually real, why isn't every roof in America white right now? That is exactly the right question, and the answer is the single most expensive physics lesson the building industry ever quietly buried. The Purdue proof is the one number that scared a $300 billion industry to silence. In 2021, Professor Shulin Ruan at Purdue University set out to create the most reflective paint surface ever recorded by science. He wasn't testing lime specifically. He was testing the physics ceiling of ultra-high reflectance coatings and what they could theoretically do to building temperatures. The formula he landed on uses barium sulfate particles engineered to scatter light across all solar wavelengths simultaneously, producing a surface that reflects 98.1% of all incoming sunlight. The Guinness Book of World Records certified it as the whitest surface ever created by humans, and peer-reviewed science in ACS Applied Materials confirmed the numbers held up under full scrutiny. But here's the figure that made the paint industry genuinely sweat. Ruan calculated that coating 1,000 square feet of rooftop with this formula produces 10 kilobars of continuous cooling power. Your standard residential central AC unit runs at 3 to 5 kilobars of output capacity. So, the paint wins by a factor of 2 to 3 without consuming a single watt of electricity. Now, here's what connects this back to the $2 powder. The physics behind Ruan's ultra-white paint and the physics behind hydrated lime are identical at their core. Both work through the same two mechanisms, and your AC system uses neither of them. Mechanism 1 is shortwave solar rejection, bouncing incoming visible and near-infrared sunlight back into the atmosphere before it ever becomes heat inside your structure. Mechanism 2 is long-wave infrared emission, radiating heat that's already stored in the surface back out to the cold sky overhead, even during peak daytime hours. That second mechanism is called radiative sky cooling, and it's the reason Professor Ruan's test surfaces actually measured below ambient air temperature during the day. The surface wasn't just rejecting incoming heat, it was actively dumping stored heat upward into the atmosphere above it. Your AC moves heat sideways, out of your house and into the outdoor air beside it. Lime and high reflectance coatings move heat vertically, radiating it straight out towards space. Space sits at 3 degrees above absolute zero. Your AC is dumping heat into 95° outdoor air on the hottest days of the year, while the powder is dumping heat into the coldest heat sink that exists anywhere in the universe. Call this the sky dump advantage. And it's the reason ancient Mediterranean civilizations ran this system at massive scale for thousands of years without ever understanding the thermodynamics. They just knew it worked every single time. If you answered C 80% on that quiz question, you're right for commercial white paint. But the physics ceiling is 98%, and a powder you can buy this afternoon gets you there for $7 a bag. The HOA rule that isn't an accident is just money. Homeowner associations across dozens of American states explicitly prohibit highly reflective roofing surfaces in their governing documents. Their rule books mandate earth tones, browns, tans, and dark grays. Specifically, the exact colors that maximize solar absorption and mathematically guarantee your AC runs from June through September without stopping. A skeptic would call that aesthetic preference, and here's what the math says in response. The global HVAC market generates over $130 billion annually. The global paint and coatings market generates over $200 billion annually. Hydrated lime is a commodity material you cannot patent. You cannot trademark calcium hydroxide, and you cannot create a subscription model for a powder that costs $7 a bag and lasts for years on a painted surface. A lime-coated roof that drops your AC usage by 60 to 70% doesn't just hurt the paint industry. It directly attacks the HVAC revenue model at its foundation. The roofing standards that favor dark commercial materials, the HOA rules mandating heat-absorbing colors, the building codes written without reflective lime coatings as an approved option. These didn't require a secret boardroom meeting to exist. They required an industry whose financial model depends on you not knowing that the Greeks solved this problem 3,000 years ago with rocks and water. But the physics layer that most people applying lime completely miss is the next one. And it's the reason Mediterranean architecture works as a total system, not just a roof treatment. Here's your second quiz before we finish the physics. A 1,000-square-foot roof coated with ultra-white paint generates how much cooling power according to Professor Ruan's Purdue study? Is it A, 2 kilowatts, B, 5 kilowatts, C, 10 kilowatts, or D, 15 kilowatts? Lock your answer in below. The thermal mass trap is why painting only a roof leaves half the physics on the table. Reflective coatings solve the solar loading trap by stopping incoming shortwave radiation from converting to heat inside your structure. But your home is also storing heat in its thermal mass. The concrete, brick, drywall, and insulation that absorb heat during the day and radiate it back inward all night long. This is the thermal mass trap, and even a perfectly reflective roof won't eliminate it on its own. Your walls still absorb solar radiation throughout the day. Your east and west faces receive direct sun for hours at their peak angles. The ground around your foundation is a thermal reservoir that bleeds upward heat constantly through the slab below you. The Mediterranean builders who perfected limewash architecture understood this intuitively, which is why they didn't just paint rooftops white. They painted every exterior surface white, every wall on every face of every building across the entire village. The physics of that decision compounds fast. A dark, south-facing wall absorbs and re-radiates heat into your living space all afternoon, turning your wall into a slow-release thermal battery working against you. A white south-facing wall with 95% reflectance converts that same exposure into nearly zero heat gain, shutting the battery off entirely. Stack that effect across every exterior surface of a building, and the thermal mass trap loses most of its power to cook you from the inside. The practical version of this for a standard American home isn't complicated at all. The roof is highest priority because it receives direct overhead sun at maximum intensity all day. The south-facing wall is second priority, taking the longest direct exposure across the full arc of the sun. The east and west walls matter most during morning and afternoon peak hours, respectively, and the total material cost of treating every exterior surface with hydrated lime is still under $50 for most residential structures, which is the number that makes the cooling industry very uncomfortable. Exactly what you do with all of this starting today is simple. A 50 lb bag of Type S hydrated lime costs between $7 and $14 at any hardware store in America right now. Calcium hydroxide is the active compound. That's the whitening agent and the reflective physics engine in the same material. Mix 1 part lime powder to 2 parts water until the consistency looks like thin paint rather than paste or mud. That formulation is called a limewash, and it's the exact recipe that Mediterranean builders have used for 40 centuries without modifying a single ingredient. Apply with a thick nap roller or a wide brush to a clean, dry roof surface in 2 full coats. letting the first coat dry completely overnight before applying the second. Total cost for an average American roof at 1,200 square feet comes to $14 to $28 in materials. A homeowner in Texas applied this formula and measured his attic temperature before and after the treatment. Before the coating, his attic was reading 143 degrees at peak afternoon. After the coating, it read 97 degrees at the same time of day, a 44-sector drop in attic temperature from 2 bags of powder and 1 afternoon of work. His indoor temperature fell 10 degrees without the AC running at full load. His estimated electricity savings for that single summer exceeded $1,200, comparing against a new AC installation running $5,000 to $15,000 up front, plus $150 or more in monthly operating costs every season. The Greeks worked this out before written language existed as a formal system. Professor Ruin proved the mechanism in a peer-reviewed lab in 2021. And the powder has been sitting on the shelf at your hardware store the entire time for $7 a bag. The most expensive knowledge the $300 billion cooling industry ever decided you shouldn't have. The most expensive square footage in your home has always been the one facing the sun. Now you know what to do with it. You now understand why passive solar rejection outperforms mechanical cooling at the most fundamental physics level. But there's a deeper heat threat that most preppers completely miss. What happens when the grid goes down and your AC stops working entirely during a summer heat wave? The physics of that survival scenario and the architecture that keeps people alive without any power at all is exactly what the next video covers. In the meantime, start with the video on the $30 homeless heat hack. It's the cold weather version of everything you just learned. And if you want the full picture, the Science of Survival playlist has every episode in one place. If this ancient cooling secret has changed the way you look at your home and your energy bills, please subscribe to our channel and like this video. We are uncovering the history and science that they have tried to bury. Let's build a more sustainable future together. The next treasure of knowledge will be opened soon.